We are going to get started. I want to be mindful of everyone's time. Again, thank you so much for joining us for today's webinar, Shutting Fire in a Crowded Room. Today's demonstration will be presented by Nick Rupley, one of our Mirth Connect developer experts, and my name is Katie Morris, and I'm a Mirth Marketing Manager. Before we delve in, for those who are not familiar with Mirth, I did want to give a bit of an introduction. Again, today we're going to be looking at HL7's FHIR and how it's different and what Mirth is doing with it. But again, intro to Mirth. Founded in 1993, Mirth has been serving the nation's largest and most respected healthcare organizations and thousands of healthcare professionals on a daily basis. Our team focuses on helping health organizations reach interoperability, data exchange, and interconnectivity goals at a lower cost of ownership. Great. I'm going to pass it over to Nick, who will give the webinar. There you go.
Thanks, Katie. So first of all, let's talk about what FHIR is. Well, FHIR stands for Fast Healthcare Interoperability Resources. So it's a new standard, a framework of standards from HL7. So this is the same organization that developed HL7 v2, HL7 v3, and the CCDA standards, all of that. So FHIR is kind of meant to replace it, but also takes sort of the best parts, what works from HL7 v2 and v3, and makes it so it's a lot easier to implement. So it's what the FAST kind of stands for. So the FAST in FHIR is really, the implementation is easy compared to other frameworks that you can start up FHIR, not know anything about FHIR, and you can have an implementation going in a day or two, and it'll be even easier, maybe even in a matter of minutes, with what we're doing with Mirth Connect and FHIR, which we'll get to later. And it's healthcare, obviously, so all the HL2 and V3 have a lot of healthcare specific in it. There's all these segments and nodes in the XML that have to do with healthcare specific pieces, and FHIR does the same thing. It does that with resources, and I'm kind of jumping ahead here, but resources are kind of the building blocks for FHIR. So there's the data format, which is made up of resources. So a patient might be a resource, an allergy might be a resource, an immunization is a resource, an organization is a resource. So all these different pieces come together into a full clinical record. And we'll talk about resources a bit later as well. The I part of it is interoperability. Obviously, it's the whole point of a standard is to get things so that multiple servers and clients can talk to each other easily. So as long as the implementation is easy, they have high interoperability because easy to adopt, and it's already based on a lot of standards which are used heavily more and more in the field. That being RESTful HTTP. So the formats are XML and JSON, but the actual transport part of it is done primarily over RESTful HTTP. So full REST standard, it has very clear rules on how to pass these resources back and forth. And the security side is left open to the implementation, so you can kind of do whatever sort of implementation of security that you want. But it does amend certain things like OAuth, and Smart on FHIR is another file for OAuth that works with FHIR as well. That's kind of a basic overview of what it is. So now that we know kind of a basic what FHIR is, how is it different from the other standards? So you may be used to using HL7 v2 and HL7 v3, other things like NCPDP for equipment. But so FHIR is really the one that puts it apart is to read the recommendation that all resources should have a human-readable narrative. Now, that's not a completely new concept because it was also there in certain CCD standards, but the intended for all resource types in in FHIR. And then we'll get into why this is important for resources in FHIR later, but this is something that definitely puts it apart. Another thing is that it's the human readable narrative is basically it can be generated from discrete data. So if you have results that have several different lab results with all these different numbers from a chemistry panel, for example, definitely take that data and auto-generate a human readable narrative in an HTML page that you can then display. Any application that can display HTML, which is basically everything nowadays, even front-end EHRs can take HTML blob and display it in the browser for a user. That's what makes it easy. It's not just the resources don't only provide a way for computers to handle the data that's coming in. It provides a way for you to actually, for anybody like a help desk user, to actually look at the resource and know semantically what that resource means. So it can be auto-generated, but it can also be free text. It's really just an HTML blob, so you can put whatever you want in there. But there's a lot of different ways that can be generated. Here's just an example of what the difference is between the actual raw XML here and what it might look like in a browser. And this is our example of what we do with a conformance resource. So on the left, you see the XML there, and it has conformance, and it has a lot of other nodes underneath of it. What we do with our FHIR implementation is we take that XML and convert it into a HTML page, which you see there on the right. So it's the same data over on the right, but we put it into kind of a nicer, easier to read format. The thing that puts FHIR apart is that it's very extensible. And it's not extensible in the sense that extensions are kind of in other standards, you might think that extensions are sort of discouraged, that you're kind of straying from the standard. But in the case of FHIR, it's actually it's pretty much encouraged. It's kind of part of the standard. Extensibility is built into FHIR from the very beginning. It's not an afterthought at all. And because the reason why this is when you're talking about two different servers that are trying to talk to each other, there's always going to be implementation-specific things that one needs and another server doesn't have, that kind of stuff. So what FHIR does about this is it introduces extensions, and extensions are really just extra pieces of information that could be on basically any part of a resource. We get resources in depth, but basically the extension is just a sub-child of that XML node or JSON node that just tells you here's an extra piece of information about it. And another thing that it supports is forward compatibility. The resources are really just XML or JSON. So because of that, any server that's to support FHIR resources can support resources from new versions that it might not know about yet. So, for example, if a completely new type of resource is added in a late version of FHIR, your older version of a server can still read that resource and decide what to do with it. It still is the basic framework structure of what XML JSON resources look like. So, and that's what these unknown elements are referred to, and those unknown elements are what support the forward compatibility within FHIR. And it's just another step in increasing the interoperability part of it. Another big thing is that it's free and open source. So, just like Mirth Connect, it's free and open source. So you don't have to have an HL7 membership to get specifications like you do with V2 and V3. Go to their site right now and download it for free. And it's also community-driven. So lots of developers around the world. It's a very international scene. All these developers come together and basically argue about what should and shouldn't be in FHIR. So, it's constantly improving. And right now it's in the standard for trial use 2 phase. But Probably, another draft standard will come out this year, and a final version of it will be released probably in a couple of years, something like that. But even right now, CA by itself is still technically in a draft standard state as well, and people are using that in production. So there's no reason why FHIR can't be used in production right now. Okay, so let's look at more in-depth examples of like what resources are, for example. So I kind of touched on this a bit earlier, but just as a recap, resources are basically the building blocks that make up what a clinical record is for FHIR. So a clinical record in CCD is your clinical document, and that contains everything about the patient, right? All the demographic information, all the allergies, all the medications, all the next of kin information, providers, that kind of stuff. In FHIR, it's a little more modulated, so you can take the patient's demographics themselves is part of a single resource. The allergy information is part of a separate resource. The medications are each their own separate resources. And very modular in that if you only care about patient's medications, then you can only search. You can just search only on the medications. So you don't have to get an entire document, filled with all this data that you might not need. You can get more granular in what you search for and what you pass over the wire, so to speak, when you are implementing with a FHIR client and server. And one way to think about this, and this is kind of taken from the FHIR website, is what they prefer to think like is thinking of resources as forms. So you go to a clinic and you fill out a form with your information, your personal information. So it would be patient demographics. So the patient resource would be a form for patient demographics. An allergy resource is a form that you fill out all these fields for what the allergy is. And what FHIR really defines is what the template for these forms look like. So what fields are in those forms, that's what FHIR specifies. And where extensions come in is when people come in and say, here are these 5 extra fields that I also want you to fill out. So we have an overview of what that is. Here's an example of what the patient resource looks like. So you see up at the top, and this is the XML example, but you can see up at the top, you can see what type of resource it is just by looking at the name of the node, the tag name there, patient, so that's pretty easy. Then under that, you have the example of what a human readable narrative looks like. So that would be in the text node there. And underneath that, that's basically your HTML there. So you have a div, an HTML div, which is a container for basically whatever you want. Add content like JavaScript isn't supported in there, obviously, but it supports all kind of major style sheets, tables, whatever you want to put in there. And underneath that, we have an example of what a medical record number would look like. And identifier is something that's in the specifications for a patient resource. You can see here's the example of an identifier, and the identifier can have multiple values. Here you have a medical record number for an identifier, but you can also have other identifiers like a social security number, some other MRN, whatever you want. The codified value is also shown here, and here's an example of how you would use something like Oink or SNOMED to okay, here for an identifier, here's the exact code it is. And that's exactly what it's in here. It's actually pulling from one of the V2 tables and pulling a value called MR. And it says, okay, what type of identifier is this? It's a medical record number. And also, and this is something that you might familiar from HL7 V3, and that's the system down there in the identifier shows a unique OID. So it's a namespace URI. It's saying, here's a unique object identifier for this specific type of identifier system, MRN. Down at the assigner level, you see the reference to a different organization. So that's how it's kind of linked together. So when you search on information and you get back these resources, kind of link together. So a patient will link to allergies and versa. And this is an example of what this might look like. So you might see an assigner and display, or you might see a reference node down there. here's also examples of what a name might look like. So inside of the patient resource, you have nodes for names. These are taken from exactly from the specifications. So you can go on the FHIR website right now, look at the specification for patient resource. Very easy to read. It tells you exactly, what the structure should look like, what value should go where. You can click through and deep dive into certain places. It's really easy to use. You can see there's two different telephone numbers here. And then here's an example of an extension. So you can see the birth date by itself would just look like that birth date value equals just that line there. In this case, it's actually also including a custom extension here for the birth time as well. So not all systems support the time of birth, maybe just the date. But in this case, if you wanted to include that, you just include it as an extension. And that extension node can actually be included really anywhere in the XML. So the whole point of an extension is you can really extend FHIR however you want. So you could put that extension inside of telecom or inside of name or inside of the patient itself. So if you want an extension that acts on the top level patient resource, you can do that as well. This is just another view of what a resource looks like. This is taken from the HL7 website as well. But it's just another way to look at how these resources are usually organized. So you see the identity and metadata up at the top. So if you have ID first, so what ID does the patient have? And this is like the FHIR ID, the unique ID for the FHIR server. It may or may not be different from an MRN. Any other metadata for it? Then next comes the human readable summary, which is optional but recommended. Any extensions could be in there as well. And underneath that, you have anything that's common for that resource type itself. So for a patient, you'll have an identifier with all these information and MRN, name, writers, birth date, that kind of stuff. But underneath that will change depending on what the resource type is. So for an organization or an allergy, you'll have different information there, and that's all in the specification as well. So here's just another view of what it looks like in JSON form. We were looking at XML before, but we could have just as easily looked at the JSON format, which is almost exactly the same. It's just kind of structured in JSON format, which some people find this easier to read as well. So it's basically anything in FHIR can be easily converted between XML and JSON. It's the structure itself is extremely easy, and you could even by hand convert between XML and JSON without too much trouble. That said, we do have tools that actually do that for you, so you don't have to do that. So now that we have an idea of what the resources are, let's look at what interactions are. So this is the other big part of FHIR. It specifies not only the format, but also the transport format. So what type of how are resources sent between the client and server? They're done with interactions. So interaction is sort of the how. Reason would be what to send. Interaction in the action defines how to send it. And by how, I mean how does this tie into the REST HTTP framework? So the way FHIR does it is it defines several interaction names. So for example, we have create, read, update, delete, kind of basic CRUD types. We also have some others like you get a specific version, read the entire history of a resource, search be a big one, search on resources with certain criteria, validate a resource, validate that the schema, validate that it's formatted and everything, or that an ID or a codified field in it, such as something in Loink or Snowbed, kind of stuff. So let's look at, for example, a create interaction. So that was one of the interactions that we showed before, create. So create a new resource with a server-signed ID. So here's how that translates into the actual HTTP request. So for a create interaction, FHIR specifies that for all create interactions, it go to the URL post, whatever your base URL is, which you could have like some extra, /API in front of it if you wanted to. After that is the type, and the type would be patient. So if you're creating a patient, it would look like post/patient, or post API/patient, or whatever the base URL might be. After there's any query parameters. So there's lots of query parameters depending on what the interaction is, and a lot of them are optional. One big one that you might see pretty often is the underscore format. It's a query parameter, and that specifies what type of resource or what type of format you want the return value to be. So creating a resource, it will, depending on what the server does, it might return a 204 no content, or it might return a 201 created. And if it returns you that the resource, if it returns the resource back to you with any IDs and metadata to the resource, then you might want to return that format in a specific. You might want to return it in XML or JSON, so you can use that format parameter to specify. And there are lots of other parameters as well based on what the action is. For example, the search interaction has lots of query parameters, and the query parameters might change based on what type of resource you're searching on. So each resource actually specifies specific query parameters that you can use for searching. For example, on patient, the FHIR specifications say that their name query parameter that you can use to search by patient name. So URL for a search might be like get/patient, then your question mark for the query parameters, name equals John Doe, or whatever. So that's the resources and how to map that to the actual HTTP. And so now that we have a basic overview of like what FHIR is and how it works, now let's get into the Mirth side of things and what Mirth is doing with that. So why should Mirth be compatible, right? So it's really just because FHIR is gaining so much traction out there, so there's a lot of buzz about it. It's been out there for a while now, actually. It's reached kind of a level of maturity in the past year or two. I see a lot of people talking about it. All the big names are have something out there for FHIR. So that's really where it's headed. And I think that FHIR is going to be big in the next few years. Especially since it's so easy to use, and I could definitely see that it's vastly improved from what HL7 v2 and v3 provide. So that's kind of like the basic why. So what are you doing? Well, Mirth Connect, if you're familiar with Mirth Connect, and we had a webinar about Mirth Connect a couple weeks ago, but basically Mirth Connect has always been able to XML and JSON, which is really all it is. Resources are just XML or JSON format, and the transport protocol is just HTTP. And so we've always had HTTP listener and senders, and we have the ability to parse and transform XML and JSON. So it's kind of Mirth Connect has always been FHIR capable, technically. Used to do the implementation work on the channel to create an HTTP listener and get in the FHIR resource and transform it, and then return the correct headers and everything like that. It's all possible. But what we're providing is a way to do that even easier than having to implement a channel from scratch. So the way we do that is we have a technology preview out. So what this is a framework. It includes a FHIR listener connector, so it's kind of like the HTTP listener, but specific to FHIR. And so it handles requests for you. It automatically parses out the request URI, the query parameters and headers, and it tells you what interaction it is, what type of resource it is. So there's a lot of data that you can glean from that in order to do whatever custom implementation that you want. Another thing that it does for you that you don't have to do at all is it will actually automatically generate HTML for serving pages within a browser. So we'll look at that in a bit, but it makes it really easy to stand up a FHIR server and have people be able to interact with your server in a browser, just like they would with any other web application. And then to go along with that, it also includes a lot of different JavaScript and Java classes and methods that you can use within your custom channel implementation for WorkFire resources and responses. So for example, if you get in a FHIR XML resource, use our utility class to take that resource in and convert it into an object, and we leverage the FHIR project in order to take that XML in, convert it to an object, and then you can call methods like getID or getName or something like that. So you don't have to parse XML or JSON manually at all. You can just use this utility classes to kind of work with it at the Java object level. So the technology preview, it's been released for a little while now, a few months, but it's free of charge. So just like Mirth Connect, it's not open source, but it is free of charge. So you can go on our website, website, and there's a section on the Mirth Connect section on the website there for downloading the FHIR technology preview. So you can go and download it right now and start playing around with it. So let's look at what this looks like in Mirth Connect. So if you are using Mirth Connect and you might be used to using the HT listener, then the FHIR listener is a lot similar to the HTTP listener. You can see a couple things up there look the same. You have the base context path and the receive timeout, the URL there, and then everything underneath that is kind of FHIR specific. So you have a place to insert the conformance template. You have other kind of general demographic information about that specific FHIR server well. You choose to support XML, JSON. By default, it supports both. And then you support, then what this does is you choose what interactions you want to support for which resources. So one thing, I did show a conformance resource off earlier, but what a conformance resource is a XML document. It's just another resource, just like a patient or anything. But it tells a client connecting to you what interactions and resources you support. So the FHIR server, what's required of you is to provide a conformance statement to clients telling the clients, hey, I support all interactions on patients, but allergies, I only support reading them. I don't support updating or deleting allergies, but I do support reading them. So you can get really granular in what is supported for which resources. So this conformance statement is required for a FHIR server, and it's really helpful as well. It's one of the pieces in the interoperability part of FHIR because it really allows any client to know that when it connects to a server, the server tells it exactly what it supports. So if it doesn't support something, then it knows that it would have to do it in a different way. So for example, if it doesn't support searching on specific parameters like the name, maybe it supports on the SRN or social security number instead. And the other thing that the FHIR listener provides is the source map variable. So a lot of these source map variables that you see here are already available for the HTTP listener. So when you request into your channel, you can look at these source map variables in the message browser and use them in your transformers to do whatever dynamic things you want to do with your HTTP request. And in the FHIR case, it actually includes some more FHIR-specific ones. So, for example, it'll always include the type resource that is sent to you. So, for example, patient. It'll include the interaction. So usually you infer the interaction based on the HTTP method type and request URI. So, for example, create was a post. But you don't have to do that at all here. It actually infers that automatically for you. So all you have to look at is that FHIR interaction variable in the source map. And there's a few other ones that also include in the source map too, based on other criteria. So what we also provide is an example channel. So we really want people to be able to kind of hit the ground running with this. So in our technology preview, and this is on our wiki page, but we have an example channel as well that you download and use with the FHIR technology preview. So it's actually it's pretty simple, but it uses a backend database to store resources, and it has several destinations that handle updating, deleting, reading sources, and also historical and searching sources as well. And they're pretty simple. They're just JavaScript writers, and all they do is they take those source map variables, they determine what the type is, what the init is, and it has everything for you. You'll be able to use that example channel in order to see exactly what a real-world implementation might look like. And for this example channel, it's just what it's doing with the FHIR resources is it's just getting into a database and then reading from that database. But also plug that in, take that and plug that in with whatever you want to do instead. If you wanted to create a FHIR listener and take resources and convert them to some other format and send them off to a folder somewhere or send them off to your EHR, you can do that as well. Okay, so now that we looked at that, let's look at what this might look like in a browser. So here's an example of that conformance statement that I showed before. So we have the conformance resource, and it shows all the resource interactions. And let me see if I can my screen here really quick. Okay, so hopefully that's working fine. So, so here's the example of what this looks like, and this is on our public FHIR server, FHIR.mirthcorp.com, and it's this is what the conformance resource looks like when you interact with it in a browser. So also this and footer stuff and this auto generation of the conformance statement, you'll get this all for free with the technology preview. So it does this automatically for you. You don't automatically generate any of this HTML, it does it automatically. So you see it has all the basic information about the FHIR server that comes in the conformance statement. You see things like the resource interactions. So it has like a little table here saying what interactions does it support, what interactions doesn't it support, like the update and delete here. It doesn't support for audit events. It also supports other things like certain search parameters. So in the conformance statement, you specify what search parameters you want to support for the overall system and for specific resources. So for specific resources, you might want to support specific query parameters. So on patient, for example, we have the ability to search on identifiers, name, family, and given name as well. And there's a lot of other search query parameters for patients. Right now it just supports these 4 as an example, but you could theoretically support much more as well. We also have operations, which are basically special kinds of interactions, and you can even do your own extension operations. So if you want to do some custom operation that fall neatly within the FHIR specification, you can create an extension for it and create that as an extension operation, and a client can look at that operation in your conformance statement and know exactly how to call that operation. And then another thing that the FHIR listener does is when it generates the HTML narrative for you. So it includes a raw content section here, so you can see what did the original XML or JSON look like. Here's the XML or JSON, and it just tells you here's the exact version of the HTML. Conformance resource part of it, and we can look at some other examples. So here's an example of searching on a patient. In here, it's just you can see it's really simple. In a browser, all you do is here's the base URL here. Here's the type, which is patient. And that you see the question mark name equals Chalmers, which is the test patient. And that tells you what query parameters and search parameters you are using. And so assuming that that patient exists in the server, it'll return what's called a bundle resource, and that bundle resource contains multiple entries. So for example, in this case, we can see that there were total entries that were returned. So you can use this in an actual client, like an HTTP client, or interact with it in a browser to test it out. Here's another example of a operation. So this is expanding on value sets. So a value set is really just a codified set of values So, like LOINC would be a type of value set, a SNOMED, or resource types. So FHIR actually provides its own sets as well. So an example is resource types, which would include, value set and patient and conformance and organization, all those. So here's an example of expanding a value set and filtering on a specific word. So as we're filtering on the word device, see here in the returned value set, the human readable narrative is this part here that displays the codes table, and all it is just shows the system, what the code name is, and the display name, which happens to be the same. There's an example of what happens when something goes wrong. So in this case, we have, I'm trying to call an operation that doesn't exist. So ASDF, it doesn't exist. It's an invalid operation, basically. So whenever something goes wrong, like, either there's an error on the server side, or maybe your client request was malformed, something like that, what is intended by the server, what is intended from their specifications, is that the server should return what's called an operation outcome. And the operation outcome just tells your client what didn't go well. So in this case, we have an error. The error tells you what type of error it is and what the details are. So in this case, it just shows you, okay, the details are this operation is invalid or unsupported. So, and no matter what type of operation outcome occurs, you can still view it in a browser. So you shouldn't get any, those browser errors where it just doesn't show the page at all. It'll still show the page, and it'll show parsed readable narrative for the operation outcome itself. So even errors themselves are resources in spec. And then while I'm still here in the browser, I just wanted to show our wiki page here. And the wiki page just shows the FHIR Technology Preview 2. So we had the Preview 1. Preview 2 is the latest here. So you can just go on our public wiki, just mirthcorp.com/community/wiki. And the FHIR Technology Preview 2 page here. You can see the overview. You can see the user guide here. Has a link to go download it. But the user guide here, and then it also shows what the example channel is. It actually has a full overview of what the sample channel does and how it interacts with FHIR. So I would definitely consider going to that and reading through that. That'll be good. Okay, let me go back to the slides here. That was quite a lot. So we covered what FHIR is, how it interacts, and what Mirth Connect is doing with it. And I definitely encourage you to go download it and start playing around with it. Build an example, use the example channel, and try to build off of it to interact with your own system, your own EHR, whatever you happen to be using. So then we also wanted to touch on what's coming next. So the FHIR specification right now is in the DSTU2 stage, with draft standard for trial use number 2, and that even though it is called a draft standard, technically even CDA is a draft standard, and kind of all specifications are really considered to be drafts. So it's not necessarily something that should put you off from using it in production. But it's still being worked on. It is an open source project with a lot of developers around the world working on it, contributing to it. And there'll probably be another version of the DSTU sometime out this year or next year. And then also we're planning on, when that happens, we're planning on following that up with other technology preview with probably even more features. Probably dedicated destination connector for sending FHIR requests, and some other new features. And definitely when the first truly official version of FHIR is released, we'll make sure to follow up with a officially released version of the FHIR listener as well. And so this was kind of a Mirth Connect centric view into what we're doing with FHIR. And Mirth Connect is very flexible, so it kind of makes sense that to be the first place to start interacting with FHIR is the Mirth Connect side, because there you can do whatever you need to. But we're definitely looking into the FHIR support for all of our other products as well, in particular results. So no additional information on that right now, but it is in the works, I will say. so, yeah, I think that pretty much wraps it up. So I guess I will hand it back to Katie.
Thank you so much, Nick. Yeah, again, thank you so much for your time. For those of you who joined us, we have recorded today's session, and we'll be sending out that recording as well as the wiki page link and anything referenced in this webinar in the email within the next few days. If you have any questions, please feel free to respond via the email if you received this. That'll be going to me, or you can head to mirth.com to learn more or contact sales. I don't see any questions coming through, so I will. Oh, actually, a question come through. Let's see. FHIR being staged to replace HL7 XADT, ORU, ORC, etc. Is FHIR being staged to replace transactions or functionality?
So really, to answer this question, in one sense, it is meant to replace HL7 v2 and v3, but in another sense, it's also meant to work with as well. So these 7 guys are, no strangers to the fact that implementations are always doing their own thing. So it definitely is expected that even though this new FHIR standard is coming out, people are still going to be using HL7 v2 and v3, and will still be using MLLP to send messages back and forth. And there is actually a module in FHIR, kind of a messaging platform that you can use within FHIR. And I would definitely look on the FHIR specifications website to learn more information about that. But it does have ways for you to kind of build in a MLLP TCP transport layer within FHIR as well. Now, that said, you still use MLLP to send FHIR resources back and forth. It supports the FHIR specification is really the data format, which is the resources, and HTTP RESTful format as well. But in the meantime, people might use it in different ways. Now the specification kind of evolves. As far as how does the transaction load stand up? Well, it's just as good, if not better. TCP, MLLP, there's really not that much overhead when it comes to HTTP, especially when you're talking about using kind of newer HTTP standard like HTTP 2. So there's a lot, and especially when you're talking about planning different requests at the same time. So it really, there's no worries about the using HTTP RESTful HTTP as a replacement for MLLP. There's not really any worries about that being any slower, if that was your question.
Great, thank you. Again, if you have any follow-up questions, please feel free to respond to any of the emails you received, and you will be receiving this webinar recording for reference within the next day or two. So thank you so much for your time, Nick. Thank you so much for really going into the heart of that. Everyone, please have a wonderful day.